Yeah. $2. Back to the charge $2.
I couldn't
Yeah.
$5 more.
Can you imagine? I was like, okay.
Hey, fellas, I'll separate y'all if y'all can't focus, okay? Let's focus. Focus, focus. Alright, we have looked already at, we're in quadratics, we've looked already at standard form. Y equals ax squared plus bx plus c. We looked a little bit at intercept form. Y equals a times x minus p times x minus q. Remember that one we did that day? We had the assignment. And then the last one that we're going to look at today is vertex form. This is the most useful in my opinion. It's y equals a times parentheses got a little loop. Let me try again. Y equals a times x minus h squared plus k. Alright, now we learned stuff to use with all of those. We learned how to find the axis of symmetry and the vertex out of standard form by doing our negative b over 2a. We learned that the intercepts in intercept form was P0 and Q0. Vertex form, the reason it's called vertex form, simple, it tells you the vertex. So if we have something that's written in vertex form, the vertex is going to be the opposite sign of whatever's in here. So the vertex would be H, and then you take the same sign of what's out there, HK. So HK would be your vertex, so you don't even have to have a formula. Carry Lynn.
When it says intercept, this is y equals a x minus b.
And that's Q, right? Yep. Same as it was. Yep.
I'll put it back on G.
Come on. I read it and we've done it before. Alright. So we got 3 different forms now that we're dealing with. And remember when we did the scootings, the translations, what was inside with the X, scooted us right or left, and it always went the opposite way? It's the same deal here. Your H is the opposite sign, your K is the right sign, and that will be the vertex of your parabola. Okay, so we're going to work some problems and decide which one we've got stuff for to use. Stephen.
Did that say modeling with quadratic functions?
Yes.
Okay.
I read it a few times, but.
Sorry.
Alright, everybody ready now? Okay, so I've got here a graph that has a point. Just going to give you a quick look at it. It's got a point that's at 0, 15. And then it's got a point that's at 50, 35. And it's going, our graph is going something like that. Okay, so we definitely see that it has a parabolic shape. That's a good word for you. Parabolic shape. Alright, so it says the graph shows the parabolic path of a performer who shot out of a cannon, where y is the height in feet and x is the horizontal distance in feet. We want to write an equation of the parabola. Then we're going to answer a question about it later. So we've got 0, 15, and we've got 50, 35. Alright, what I didn't draw very well on that, but I'll tell you now, it's close. That 50, 35, if it's on that axis of symmetry, what would that be? What part of the parabola is it if it's on an axis of symmetry like I just dotted? What's the name of it?
What does it start with?
V, and we just wrote it.
Vertex.
Vertex. So 50, 35 is my vertex, which means if I'm going y equals a, x, okay, it's a positive 50, so what sign will go in here? Good, Jody. Squared plus k. Oh, that was Crystal. Sorry, Crystal. And I know my k, so plus 35. Now, we're told just to write the equation to start with, and we've almost got it done. Because we know that we've been working with these parabolas for a while, and we know we're going to leave a y and an x, but what we can't leave is an a. We have to actually get a number for a, because the a tells us some stuff about it. So what you're going to do now, we've already used the vertex point. They gave us another point, 0, 15. We're going to plug that in and algebraically solve for a. Alright, so I got y, which is 15, right? So I got 15 equals a, x is 0. Right, see where I got the 0 and the 15 from? Now I'm just solving this for A. 0 minus 50 is negative 50. What's negative 50 squared?
250.
Is it 250 or is it 2,500?
Well, that's the same thing.
No, it's not.
Oh, no. No, I don't think you're right.
I think you gonna add 2 zeros, right? 2,500? I know, I'm not reading that. What, I gave you a calculator.
Wait.
What? I'm waiting. Tell me. Do I need to go up, that back down? Is that what you're saying? I got you. Well, okay. So what we've got down there now, where it says 15 equals A times 2,500 plus 35, that's just normal two-step middle school equation. We're trying to solve for A. It's got 35 being added, so we're just going to
Subtract 35.
Yes, subtract 35. So what was that?
Negative 20.
Equals A times 2,500. We're trying to solve for A.
You don't distribute that A, do you? To 25?
Well, yeah, you
You
could,
can.
but it would mean what I've already, it wouldn't change it. I'm trying to solve for A. It's being multiplied by 2,500, so I want to
Divide by
by
2,500.
2,500.
You have to put that 2,500 in parentheses, or
No.
just makes it easy.
So it doesn't look all jumbled up. Alright, so that's going to be negative. It's not pretty. What is that? 2 out of 250, 1 out of 1/125th. Is that right? Somebody divide that and check me out. I think it's negative 1/125th.
Can we put it in the fraction?
Get math, enter, and change it to a fraction. Is that what you got, Molly? Okay, good. Alright, so that's my A. So all I got to do now is take that, plug it back in here for the A, and I've got my equation.
So you start with that normal one we made.
Y equals negative 1/25th times x minus 50 squared plus 35. That's your equation. Okay, so we were given a vertex, so we plugged that in for the h and the k. They gave us another point, so we used that point to solve for A, and then we just wrote the equation. So now we've got an equation for that person that's getting shot out of the cannon.
Now we're solving for
We're going to
X.
volunteer Trevor for that. No, we don't have to solve for X. We're good. But you just got it. The question that I want to go along with this now says the performer lands in a net 90 feet away from the cannon. How high is the net? Okay, so if let's go back and look at my picture. If this is here at 90 feet away, that's 90 comma something. How high is that? So all I got to do is go to my equation and plug a 90 in for the x and see how high up he is. So negative 1/25th times 90 minus 50 squared plus 35.
Do 90 minus 50.
Hey, y'all keep going and work that out. I want to know how high, if we need to get a ladder to get Trevor down out of the net or not.
100.
Is it supposed to be 1/125th or
1/125th. You're right. I forgot a 1 there.
Oh,
Hey,
would
look at what I did right here that Crystal showed me. My A is 1/125. I forgot a 1 right there.
Is it still 90 minus 50?
Yeah,
Okay.
90 feet. Yeah. That's a long way that we shot Trevor, by the way.
Yeah, not very nice.
Yeah, I've been confused on that. You've been doing 125 and 20.
Yeah, Kristen got us fixed, so we're good now. Sorry about it, Landon. I messed up. I do it 7 times a day.
What are we solving for around here? Why?
Okay, since we're actually trying to find out if we need a ladder to get him or not, it'd be a good answer to be in a decimal. I do 11 divided by
You go to hell.
That's all it takes.
I got this
That's
number.
Yeah.
Dude, get the-
Now we're never gonna get Trevor back. Trevor, we're really gonna shoot you out of the cannon if you can't keep your hands to yourself.
Negative negative 1 over 125.
What is it, 3 done?
I'm not gonna hit you. Ooh. I don't think I got this right, but
What y'all get it in?
1115 over 5.
That's
Oh.
right, Trevor, but I wanna know if I need a ladder to get you, so put that in a decimal so I'll know better what it
How do you
means.
change it to a decimal? Straight letter to
Enter,
Go
enter.
down.
Plus 35.
Shit, math in there.
It's already in it, Frank.
What, 111 over 5 is not wrong?
Okay, I'm just checking something else. Alright, I've been here at 111, listen, I've been here at 111 over 5, and that is right.
22.2.
But remember, we're actually talking about somebody getting shot out of a cannon and landing in a net. So if you tell me that he is 111 over 5 feet high, some people might not really know what that means. So this will be a good time to go ahead and put it in a decimal. Now we got the decimal, we know that Trevor's laying in the net 22.2 feet up in there.
Wait,
So-
if we shot him 90 feet in the air, how did...
No, we shot him 90 feet away. So he landed like up here in our picture.
Got shot 30 yards.
He went the distance 90 feet. It's up 22 feet. Does that make sense? Okay. So we're going to have to get a ladder, possibly even a ladder like on a bucket truck or a fire truck to come get him out of that net.
Would you do that?
But if we shot him out of a cannon, he probably could just jump out of the net
Did you
too.
do... Wait, 90...
Well, I mean, he's got 22 feet to fall.
Would you let me shoot you out with a cannon?
No, I'm not volunteering for that.
Would you scout out?
I will.
Jump out the street.
I will.
Would you go scout
Do
out?
like a fraction.
I-
Do you have a bucket wish?
Like do negative 1
I've got several.
You get all the jobs and you want everything on the floor, jobs, you have like a list.
Square. And then plus 35.
Indoor.
You said, wait,
And then you go
No, it was this, not wish.
you said, wait.
I did? I meant it.
Alright, now, got another one. Everybody done with that one? Shh, you ready, Gabe? This time we've got a graph. Shh, y'all simmer down. Got a parabola that looks something like that, and I'm just showing you the points so we know that that would keep going. This point up here is at 0 and 9.6. This point here is at 4, 0. And then this point here is at 24, 0. Okay? The direction, here's what the problem says. A meteorologist creates a parabola to predict the temperature tomorrow, where X is the number of hours after midnight and Y is the temperature in degrees Celsius. Write a function f, so that means it's going to be f of x. Write a function f that models the temperature over time and what is the coldest temperature. So we've got to write the equation for that parabola. We just have to put it in terms of f of x. Okay, now we talked about standard form, vertex form, and intercept form. So do I know what the vertex is just by looking at that picture? No. So I'm not going to use vertex form. What are those points that are on the x-axis? What are those? They're intercepts. So we're going to go to intercept form. Okay? Intercept form, yes, says that. We're going to do f because they told us to. F of x equals a times x minus p times x minus q. That's what we're going to plug in. And we know our p and our q, right? Aren't those the intercepts? P and Q's the intercepts, so 4 and 24, right? So I'm going to have f of x equals a times x minus 4 times x minus 24. Okay, now we're in the same dilemma that we were in the last period, last problem. We got to solve for a.
How do we do that?
So would you plug the 0 and
9.6, that's a 9.6, yes. We're going to take that other point and plug it in and solve.
So it means x will equal 0.
So I'm gonna have 9.6 equals A. Now, what X am I gonna put here? Stephen just said it. 0 minus 4. And then X again is 0 minus 24. So that's easy. We've got 9.6 equals A times negative 4 times negative 24. Okay, negative 4 times negative 24. I think that's 96, isn't it? So we got 9.6 equals 96A. We're trying to solve for A.
You gotta divide by 96.
Good job, Mr. Trevor.
Mr. Trevor don't know.
So what's our A on this one?
You want to do a fraction?
Oh, what do you got, Stephen? I'll take either right now. 9.6 divided by 9.1. Thank you.
I pressed the wrong button. I pressed the negative side.
Well, that'll do. Alright, so we're, say that again. Scoot it up just a second, clearly. So now I'm going to go back to right here where we started our equation, and I'm just going to put the 0.1 in for the A. So I'm going to say f of x equals 0.1 times x minus 4 times x minus 24. Now, when I read the problem to you, it said write a function in terms of f. I've done that. So I'm done. I'm circling it. It could say something mean to you like write in standard form or vertex form. If it did, you'd have more work to do. Like to get to standard form, we would now have to multiply these two and then distribute a 0.1, right?
Yeah.
Okay, but we're not doing that. We're there. Okay. The question also said, which we might have to do that to get this. The question also said, what's the coldest temperature? Okay. So we're looking for this minimum value, right, for the coldest temperature. Now, do what?
No, I just solved it.
Okay, that's fine. You went ahead and multiplied it out. That's fine. We're looking for the coldest temperature. We're looking for the minimum, which means we need to find the vertex. And when we talked about intercept form that day, we had a worksheet. I gave you a shortcut on finding the vertex. Wasn't it just P plus Q and half it?
Yes.
Remember that? So 4 plus 24 is 28. Half of 28 is 14. So now I got to plug a 14 in and solve.
Wait. You say 4 plus 24 is 28.
Okay?
If they were negative, you take the opposite of it?
Look at that P and Q right here.
Oh, I thought we were doing this one over.
So we're trying to find the vertex. Guys, y'all aren't going to have a clue how to do this come test time. Just saying. Trying to find the vertex. 4 plus 24 is 28. Half of that is 14. So I'm going to plug 14 in here to solve for y, to find out the coldest temperature. So I've got 0.1 times 14 minus 4 times 14 minus 24. So that's 0.1 times 10 times negative 10.
Yeah.
So 0.1 times negative 100 will be negative 10. So the coldest temperature that they measured, and this is in Celsius, so don't freak out and be like, it's not possible, will be negative 10. So that'd be like 22 something Fahrenheit, wouldn't it? Somewhere around in there.
That's real cold.
Yeah, it is. It is for sure. For sure. Okay. It doesn't say where it is. I'd be interested to know where they were taking that temperature there. All right. We got it? Got that one? Okay, look at this. I've got for us here a table. It's got my time. That's hard to read. Let's try again. It's got my time. This will be my x's. I was like, all right, good. And then I got my height, which will be my y's. All right, my time's counting by 5, starting at 10, so we're going from 10 to 40 by 5s. Oh, yeah, okay. Probably. Then my heights, I got 26,900.
So yeah, count by 10.
Fives on the, my heights are just, no, they're not counted by anything specific yet. 29,000, 25, 30,000.
You get 30 on your top.
Yeah, I see it. I'll get it on. Thank you, Chloe. 30,600. I'm at 25. Then I gotta fix that Chloe saw. 31,625. Okay, I missed 30 there. Chloe found for me. Thank you. Okay, 30 would be 32,100. 35 would be 32,025. And the last one's 31,400. So you see it starts coming back down, which would signify parabola. Okay, says here's the problem that goes along with this. NASA can create a weightless environment by flying a plane in a parabolic path. The table shows the height in feet of a plane X seconds after starting the flight path. After about 20.8 seconds, passengers began to experience a weightless environment. Write and evaluate a function to approximate the height where this occurs. Alright, so this time we don't have a vertex. We don't have any intercepts. So this is actually, out of the three types of equations that we're going to have to write today, this is the one that takes the longest because we're going to be going to standard form. Okay, in standard form, we're going to be basing it off of patterns. Okay, so here's what we're going to do. I'm going to write these out. Got 20, so I'm writing them out horizontally so we can see the patterns. 26.9, 29, 25. I'm not going to have room to do that there. Let me go down here. 26.9. I'll scoot it on just a second. I'm just writing them out horizontally. 29, 25. 3,600, 31, 625, 3,200, 3,100, 3,225, and squeeze that last one in there, 31,400. Alright, so what I want you to help me do here, and this is what you have to do when you don't know vertex, when you don't know intercepts, is we got to start trying to find a relationship between these. So tell me what you get when you subtract there. What's 29,025 minus 26,900? Okay, so now do 3,600 minus 2925.
1575.
Okay, so we already know, and you knew this anyway because we're doing quadratics. Since we don't have the same difference here, we already know it's not linear. But let's keep going because we might see something else. 31, say it again, 10, 25, and then the next one.
475. Is that a 7? Or 32?
What do you look right here?
The next one.
On 32,025. This one was 475. That one I got negative 75.
Yes.
And this one I'll get negative 625. Okay, so we're not linear. If this had subtracted the same thing every time, it would make a line on the graph. That's not linear. But we can go one more level and check differences, and if we get a constant difference in these levels, that will tell us it's quadratic. So that's what we're checking now.
It's negative 500.
Okay. No, that's not what I got.
Why would it be the same? Negative 550, not enemy 500. 550, negative.
Negative 550. Not the same as negative 500. Okay. What we get here?
Same.
Is everybody else seeing that? So we get negative 550 all the way across on that. So when that second level is the same difference every time, that tells us that we've got a quadratic. So we got to try to write this in standard form. Now what we're going to do, and this is going to take it back to, I told you it's a longer problem, it's going to take it back to the systems of equations where we had x, y, z stuff. Okay, so we're going to have to write three equations with three variables on our x, y, z. So you can pick, I'm just going to use the first, I'm going to use 10, 20, 30. Okay, those are the points that I'm going to use. So for my first equation number 1, the 10, so I've got, that'll be my x, we're writing in ax, by, c, we're writing into that. So I'm going to have 10x plus the y that goes with 10 is 26,900. So plus, hold on a second. We're doing a quadratic. So that's my fault on that. The quadratic, these are going to be squared, right? Because this is a quadratic. I said that and then I didn't write that. So that when I square x, 10 squared is 100, right? So that's better sense there. So
Wait, why is that one stuck out there in front of
Yeah,
me?
you got one spirit.
because this is equation number 1.
Okay.
So I've got 100x plus, well, let's put an a up there since I got a's written up there. I need to keep all my variables the same. 100a, can't be switching variables, that really confuse you. And then I got another x, so it's still 10, but that one's a b, right? And then I don't have any idea what c is. And what point went with 10? 26,900, right? Okay, and then for equation 2, I said I was going to use 10, 20, and 30. So I'm going to do 20 squared. So that's going to get me 400a plus 20b plus c. And 20 went with 30,600. Then for my third equation, 30 squared plus 30b plus c, and let's see, what did 30 go with? 32,100. Okay, so now we've got our 3 equations like we've done before. We've got to start trying to eliminate a variable and solve.
None's the same. It's at C's.
Yeah, so we can eliminate
That's
c's.
who,
I don't have a problem with eliminating c's. Is that all right with everybody?
first and second.
So let's subtract the first 2 to eliminate the c. So 100 minus 400 be negative 300a. 10 minus 20 is negative 10b. C minus c is gone. What's 26,900 minus 3,600?
26,900 plus 3,600.
30,600.
30.
Negative 3,000 something. Or negative 5,000. Negative 3,000 something. What did y'all get?
Negative 2,000.
Negative 3,079, like that. Well, you're the one that typed it in. I'm waiting on y'all.
I'm trying to make sure. I
That's
got-
right.
Oh, okay. You had it, Trevor. Be confident. Thank you, Chloe. All right. So that was by putting the first 2 together. So you want to just put the last 2 together now? Is that okay?
Yeah.
Subtract it again on those. So 400 minus 900 gives us negative 500a. 20 minus 30 gives us negative 10b. C's are gone. So we're doing 30,600 minus 32,100. Negative 1,500.
Yes.
Okay, good. Now, that was you see maybe, hopefully, the reason I chose the ones I did, 10, 20, and 30, because now when I subtracted those, I got 10s on both of those B's, so they're ready to eliminate.
So now we gotta add.
No, the same sign on the B, so we subtract.
So
So negative 300 minus negative 500, that'll be 200. Negative 10 minus negative 10, he gone. What is negative 3,079 minus negative 1,500?
Oh, shoot. It's I thought it was 3,000.
1,579 negative.
Whoa, what?
No.
It's 3,700.
Okay. On this right here?
Yeah.
Okay.
Oh. hold on, never mind.
Okay.
Sorry.
That is 3,000. Yeah, that's right. That's what I said earlier, but I was.
This is supposed to be 3,700.
Yeah, I was second guessing myself. Negative 3,700. Yeah.
Okay.
That's my fault for
okay.
second guessing
That's okay.
myself.
All right, so now you're doing negative 3,700 minus negative 1,500, and what do you get?
Oh, wait, yeah.
Say it again, Clark. Negative 1,200. Is that everybody? Everybody good on that? Okay. It's being multiplied by 200, so we're dividing by 200. So everybody got an A of negative 6. Is that right?
No, it was 2,200.
Yeah, negative 22.
Yeah, I was about to say, that's not right.
I'm going to have to quit trusting, I guess.
It's negative 2,200.
Negative 2,200, so negative 2,200, so we divide that by 200, that'd be negative 11. Is that
Yes,
right?
right.
Well, I got negative.
You got
So
negative
we
what,
got
Molly?
A now.
I got negative.
I mean,
I started doing like 4 answers.
I second
now we've got to take negative 11 and plug it back in one of those new ones to find our B. Okay, so you want to do the one with 300 or 500?
500. 500.
Okay.
Negative 500 times negative 11 minus 10 equals negative 15.
Well, you would divide that by negative 600, so right?
So,
I'm gonna watch it in first period.
Alright, Trevor said he's plugging it in here, so I've got, oh, something must be wrong somewhere. I have to look over there. Negative 500 times negative 11 minus 10b equals negative 1,500. What's negative 500 times negative 11?
5,500.
Negative 5,000.
No, it's
No,
negative
it's
times a
not.
negative, so I got that
Lost it.
posted.
God.
Okay, so now we're going to subtract 5,500 from both sides.
You get 4,000.
So that's negative 10b equals negative what? I
7,000.
think that's right, Steve. Negative.
Negative 7,000.
Oh, shoot. Wait, what is it? Negative 1,500 subtract?
Negative.
I really did it out.
Okay, then we're dividing by negative 10,
Which is 7.
and we get B is 700. Okay, we've got an A, and we've got a B. We got to go back to one of our originals now to get a C. Okay, so pick our favorite. Pick our favorite original. Anybody care? I'm just going to do the first one.
I don't know if I'm right or wrong on this, but it's, maybe I have it wrote. Is it negative 1,500 minus 5,500?
Yes.
Negative 1,500 minus negative 5,500.
No, you got too many negatives in that. Just
What's
negative,
not negative?
negative 1,500 minus 5,500.
Alright, so, never mind, I don't know. I'm sorry.
You're right. Okay, so I'm plugging those in my first one. So 100 times negative 11. And then I've got my first one written in my book over here. 10 times 700 plus 10 times 700 plus C is equal to 26,900. Okay. So that gets us negative 1,100 plus 7,000 plus C is equal to 26,900. Combine this. What's negative 1,100, bless you, plus 7,000? 5,900 plus C is equal to 26,900. Subtract Dalton's 5,900. And C would be 21,000. Okay, so we got
got our A,
C.
B, and C.
All right, now remember, what we were looking at here was this is actually a parabola, so we were getting standard form ax squared plus bx plus c. So we're going to write f of x is equal to 11x squared plus 700x plus c.
This whole problem took 20 minutes.
Those are the longest time, for sure. Vertex form and intercept form are always a lot shorter and sweeter.
That f of x.
Yeah.
When would we use this in real life?
Well, that actually came from a NASA problem.
So if we went to NASA, we'd use it?
That
Oh,
one, yeah.
You're gonna use it on there.
Maybe.
Yeah, possibly could do some plot patterns.
Even if I'm just working on them with a wrench.
Right, that's all you're gonna use.
One wrench.
He's gonna carry that thing in his pocket every day.
Yeah, one wrench.
You know that when you go into engineering for the Air Force, that you're gonna be engineering everything else?
No.
Drag race.
Okay,
Aircraft.
what we're gonna look at, listen Gabe, what we're gonna look at on Monday, we're gonna just do some review assignment, over some parabola stuff. I mean Tuesday, thank you. I am excited that we get day off. Tuesday, gonna have a review assignment. It's not gonna be those, guys, are y'all gonna quit talking? It's not gonna be those like we've done the last couple of days. It's a little bit different format, some review assignments. And then we'll start reviewing everything together so we can have just a quadratic test before we get a lot more info in it, okay? So Tuesday we'll have an assignment and then we'll start reviewing over some stuff, all right? We just got a couple minutes because of the pep rally schedule, so.
We got 50? Yeah. What time is
I
that
think
pep rally?
we get 45.
2:45.
We get at 45?
It's 2:45 to 3:50.
So, is this the first one?